In this session, the topic I am going to take up is determinants. First of all, what is a determinant? Determinant, it is a function which associates to each square matrix a unique value or expression. All the matrices involved in determinants are square matrices. Determinant exists only for square matrices. So it is a function which associates to each square matrix a unique value or expression. Determinant of a square matrix A is denoted by A within straight bars, read as determinant of A within straight bars. Now I come to determinant of a 2 cross 2 matrix. Now we define determinant as it is a function which associates to each square matrix a unique value or expression. How this value is associated, I will discuss now. First of all, I take up 2 cross 2 matrices. Then I will discuss for 3 cross 3 and then in general. So first of all, we discuss how to find determinant of a 2 cross 2 matrix. Let A be equal to A11, A12, A21, A22. That is a general matrix of order 2 cross 2. Then determinant of A is defined as this into this. That is A11 into A22 minus this into this minus this into this. That is A21 into A12. That is this minus this. This into this minus this into this. For example, A is equal to, say, we have to find determinant of this square matrix. So what we do is determinant is this into this minus this into this. Determinant is written in straight bars. Matrix is written in square brackets. Now determinant is this into this minus this into this. So 1 into 9 minus 7 into 3. That is 9 minus 21. That is equal to minus 12. So minus 12 is the value of this determinant. So I have told you how to associate a value to a 2 cross 2 matrix. The method is this into this minus this into this. Now I take up very simple examples and then we will move on to 3 cross 3 determinants. Now first question is, if A is equal to this much, find the determinant of the matrix A square minus 2A. So first of all we will find A square minus 2A. Now to find A square minus 2A, we will first find A square. So A square is equal to 1, 3, 2, 1 into 1, 3, 2, 1. A square is A into A. So this is equal to this into this. That is 1 into 1 is 1, 3 into 2 is 6. So 1 plus 6 is 7. So this into this. 1 into 3 is 3, 3 into 1 is 3. So 3 plus 3 is 6. Next is this row into this column and this column. So this into this is 2 into 1 is 2, 1 into 2 is 2. So 2 plus 2 is 4. Now this into this is 6. 3 2s are 6, 1 into 1 is 1. So 6 plus 1 is 7. So we have found A square. Next is to find A square minus 2A. So A square minus 2A is equal to, now A square is 7, 4, 6, 7 minus 2a. So we prefer plus sign outside. So we will multiply a by minus 2. Multiply a by minus 2. So minus 2 into a is minus 2. Minus 2 into 3 is minus 6. Minus 2 into 2 is minus 4. Minus 2 into 1 is minus 2. So this is equal to this much. And this is equal to, now 7 minus 2. We will add the corresponding entries. So 7 minus 2 is 5. 6 minus 6 is 0. 4 minus 4 is 0. 7 minus 2 is 5. 7 minus 2 is 5. So this is equal to this much. And therefore determinant of a square minus 2a is equal to this into this minus this into this. This into this is 5 into 5 is 25 minus this into this is 0. So this is equal to 25. So value of this is 25. Now next I take up evaluate the determinant this. Now this determinant involves logs and we will be using two very simple formulae from logs. First is log m to the power of n is equal to n log n. Base is a. Log m to the power of n is n log m and base remains unchanged. And here second is log a to the base b is equal to 1 upon log b to the base a. These two are interchanged. 1 upon log b to the base a. Now given determinant can be written as log 512 to the base 3. Now 512. Now 512 is 2 into 2 is 4. 4 2s are 8. 8 2s are 16. 16 2s are 32. 32 2s are 64. 64 2s are 128. 2s are 256. 256 2s are 512. So 512 is 2 to the power of 9. So 512 is 2 to the power of 9. So we can write log 512 to the base 3 can be written as log 2 to the power of 9 base 3. This can be written as log 3 to the power of 4 and log 8 to the base 3 can be written as log 2 to the power of 3 to the base 3. And log 9 to the base 4 can be written as log 3 square. 9 is 3 square to the base 4. Log 3 square to the base 4. 9 is 3 square. Now we can, using this formula, we will take the power out. Power will come out. And this can be written as 9 log 2 to the base 3. This is log 3 to the base 4. This is 3 log 2 to the base 3 using this formula. And this is 2 log 3 to the base 4. Now if we interchange a and b, so this will become log 4 to the base 3. So base will change to 3 and here also the base will change to 3. So base of all these logs will become 3. So what we do is we write this equal to 9 log 2 to the base 3 and this can be written as 1 upon log 4 to the base 3. This is 3 log 2 to the base 3. this can again be written as 2 into 1 upon log 4 to the base 3 using this formula. We have used this formula here and here. So this can be written as, this is equal to 9 log 2 to the base 3 1 upon log 4 to the base 3 can be written as log 2 square to the base 3. This is equal to 2 log 2 to the base 3. So this can be written as 2 log 2 to the base 3. So this can be written as 2 log 2 to the base 3. And this is 3 log 2 to the base 3. 1 upon, this is 2 into, now this can be again written as we have explained here, this is 2 log 2 to the base 3. This 2 cancels with this. And this is equal to this into this. This will be 9 log 2 to the base 3 into 1 upon log 2 to the base 3 minus this into this minus this into this, minus 3 log 2 to the base 3 into 1 upon 2 log 2 to the base 3. And this is equal to, now this cancels with this and this cancels with this. So we are left with 9 minus 3 by 2. That is equal to 18. 18 minus 3 is 15. 15 by 2. So this is the answer. 15 by 2. The next topic I am going to take up is minors and cofactors. First of all, I will define minor. Let A equal to Aij, n cross n be a square matrix. Then minor of an entry Aij is defined as the determinant of a square submatrix obtained by deleting the row and column in which the entry occurs. So if A equal to Aij is a square matrix, then minor of entry Aij is the determinant of the square submatrix obtained by deleting the row and column in which this entry occurs. For the entry Aij, we will delete the ith row and jth column. Then by deleting the ith row and jth column, we will get a square submatrix. And determinant of this square submatrix will be the minor of the entry Aij. And minor is denoted by minor of Aij is generally denoted by Mij. Now I will define what do we mean by cofactor. Cofactor of an entry. Then I will illustrate you how to find the minors and cofactors. If A equal to Aij n cross n be a square matrix, then cofactor of Aij is denoted by capital Aij and is defined as Aij equal to minus 1 to the power of I plus j into minor of Ij. That is, we can regard cofactor as minor with proper sign. Cofactor as minor with proper sign. Proper sign. We can regard cofactor as minor with proper sign. If sum of this is odd, it will be negative. If this is even, sum is even, it will be positive. Now I take up few examples to illustrate how to find minors and cofactors. Now first example is let A be equal to this much, then find A32, that is cofactor of the entry 3, 2 and minor of the entry at the place 2, 3. And second is the minors of first row, third is the cofactors of second column. So first of all we will find A3, 2. First is A3, 2. So this is equal to minor with proper sign, minus 1 to the power of 3 plus 2 into M3, 2. And this will be equal to, now this is 5, 5 is odd, so this will be minus. So this will be minus M3, 2. And this is equal to minus, and this is now minor of the entry at the place third row and second column. First row, second row, third row. Third row and second column. Third row, second column. So this is the entry. Now we have to find M3 to delete the row and column in which this entry occurs. That is, we will delete the third row and second column. That is, the third row will be deleted and second column will be deleted. So we will get 1, 2, 4, 2. So we will get 1, 2, 4, 2. Now determinant of this matrix is equal to this into this is 2 and this into this is 8. 2 minus 8. So this will be minus 2 minus 8. So this is minus 6 minus minus plus. So this will be equal to 6. Now second is M2, 3. That is minor of the entry at second row and third place. So we will delete second row and third column. So second row, first second row will be deleted and third column will be deleted. So this and this will be deleted and we are left with 1 minus 3, 3, 5. So we will be left with 1 minus 3, 3, 5. And this is equal to 5. This into this minus this into this. Plus 9. So this will be equal to 14. Now second part is the minors of first row. So we will find the minors of first row, that is this. Now minor of first row will be M1, 1. Second minor will be M first row second column, and the next minor will be first row and third column. So minors of first row will be 1, 1, 1, 2, 1, 3, 1, 1, 1, 2, 1, 3. So this will be equal to, now in this case what we will do is we will delete the first row and first column. So first row and first column. This will be deleted and we will be left with minus 1, 2, 5, 2. Minus 1, 2, 5, 2. Determinant of this will be the minor. And minor of entry 1, 2. First row, second column. First row is this and second column is this. So first row and second column will be deleted. First row, second column. 4, 2, 3, 2 will be left. 4, 2, 3, 2. And similarly, M1, 3. First row and third column will be deleted. First row, third column. We will be left with 4 minus 1, 3, 5. So we will be left with 4 minus 1 and 3, 5. Now evaluate these determinants. This will be this into this minus this into this. So minus 2 minus 10. 10, that is minus 12. This will be equal to this into this minus this into this, that is 8 minus 6, that is 2. And this will be equal to 20 plus 3. 20 plus 3, that is 23. So these are the minors of first row. Now we find the cofactors of second column. Second column is first column, second column. We find the cofactors of this column. Now place of this entry is first row, second column. So this will be first row, second column. Then next will be this entry. So this will be second row, second column. So this will be second row, second column. And the next will be this. So this is third row and second column. So this is third row and second column. This is equal to, now what we see here is we have to find the cofactors of second column. So column is remaining fixed, 2, 2, 2, and row is varying. This entry is in the first row, this entry is in the second row, this entry is in the third row. Second column is fixed, first row, second row, third row. First row, second row, third row, and column is remaining fixed. In case of minus, we were finding the minus of first row, so row was fixed. This row, row, row is fixed, and column is varying. First row, these are the entries of the first row. So row is remaining fixed and columns are varying. This entry is in the first column, this is in the second column, this is in the third column. So what we get here is, now cofactor of 1, 2 will be minus 1 to the power of 1 plus 2 into m 1, 2. So this will be minus 1 to the power of 2 plus 2 into m 2, 2. And this will be equal to minus 1 to the power of 3 plus 2 into m 3, 2. So this will be equal to minus 1 to the power of 3, that is minus, and this will be m1, 2. And this will be equal to 2 and 2 are 4, so plus. This will be plus m2, 2. And this is again odd 5, so this will be equal to minus m3, 2. Now this is equal to minus, and delete first row and second column. First row and second column. First row, second column will be deleted and we will remain with 4, 2, 3, 2. So we will get 4, 2, 3, 2. And here this will be equal to, now second row and second column will be deleted. So second row, first row, second row. So this will be deleted and second column, first, second column. So second column, second row. Second row, second column. Second row, second column will be deleted and we will get 1, 2, 3, 2. So this will be 1, 2, 3, 2. And this is equal to minus, now in this case, third row and second column will be deleted. Third row, first row, second row, third row. Third row and second column. Third row and second column. Second column is third row, second column. We will be left with 1, 2, 4, 2. We will be left with 1, 2, 4, 2. So this can be evaluated as minus, this is 8 minus 6. This is 8 minus 6. This is equal to minus 2. And this will be equal to 2 minus 6. So this is equal to minus 4. And this is equal to minus of 2 minus 8. 2 minus 8. So this is equal to minus minus plus plus 6. So these are the cofactors of second column. So now we understand, in order to find minor of any entry, we delete the row and column in which the entry occurs. we now discuss determinants of matrices of order 3. Order 3 means square matrix of order 3 cross 3. So we discuss determinants of square matrices of order 3 cross 3. Let A be a general matrix of order 3 cross 3. Now, in order to find the determinant of this matrix, that is, we will find the value which can be associated with this 3 cross 3 matrix. Now, what we do is we can find this value of the determinant by expanding this matrix either by row 1 or row 2 or row 3. All these values will be same. Even if I expand this by C1 or C2 or C3, the value will come out to be same. And this value is the value of the determinant. So how we associate to this matrix a unique value? First is, say we expand this by R1. That is, we find the value of the determinant by expanding it from row 1. Now the procedure is, this is the first row. What we do is multiply each and every entry of R1 with the corresponding cofactor and add the result. Multiply each and every entry of R1 with its corresponding cofactor and add the result. That is, what we do is A11 multiply by its cofactor A11 plus A12 A12 plus third entry is A13 A13. So this value is the value of the determinant. Similarly, we can expand this by, say, expanding by R3. This is row 3. Now these are the entries of row 3. We multiply this entry by its cofactor, this entry by its cofactor, this entry by its cofactor and add the result. We will get the value of the determinant. So determinant of A, if we expand it by row 3, it will be A31 into capital A31, A32 into capital A32 plus A33 into capital A33. And similarly, we can expand this by, say, expanding by C1. Now this is C1. So what we do is we multiply A11 with its cofactor capital A11, A21 with its cofactor capital A21, A31 with its cofactor A31 and add the result. So determinant of A will be equal to A11 into capital A11 plus A21 into capital A21 plus A31 capital A31. And similarly, if we expand this determinant by C3, what we get is, this is C3. So A13 into capital A13 plus A23 into capital A23, A33 into capital A33. So this is the value of the determinant. And similarly, if say A is equal to this much, say A11, A12 up to so on A1 and A21, A22 so on A2n and so on up to nth row. So this will be AN1, AN2 up to so on ANn. Now if we want to expand this determinant by, say, expanding by R1. Now if we expand this determinant by R1, what we will get is determinant of A is equal to, now R1 is this, so we will have A11 into capital A11 plus A12 into capital A12 plus so on plus A1n into capital A1 N. And similarly, if we expand this by say C2. Now this is second column. So what we will get is determinant of A is equal to second column. So this will be A12, A12 plus A22, capital A22 plus so on plus AN2, capital AN2. And all these results can be written in terms of minors also. In terms of minor, this can be written as A11 and A11. A11 is capital M11 because this is an even place entry. 1 plus 1 is even, so we will have this. Basic result is Aij is equal to minus 1 to the power of I plus j into Mij. So A11 will be minus 1 to the power of 1 plus 1, 2, that is positive, M1, 1. And this is 1 plus 2. 1 plus 2 is odd. Odd is negative. Therefore, minus A12, M1, 2. Plus 1 plus 3 is even. So, plus. So, this will be M1, 3 into A1, 3. And this can be written as A3 plus 1 is even. So it will be positive. A31, M3, 1. 3 plus 2 is odd. Minus A32, M3, 2. 3 plus 3 is even. So A33, M3, 3. And this can be written as 1 plus 1 is again even. A11, M1, 1. This is odd. Minus A21, M2, 1. Plus A31, but 3 plus 1 is even, so plus. So this will be M3, 1. And this can be written as A13, 1 plus 3 is 4, 4 is even, M1, 3. Plus A23, M2, 3. Plus A33, M3, 3. Because this is a even place entry. Now here this can be written as A11, M1, 1 is odd. So we will have minus A12, M1, 2 plus so on plus minus 1 to the power of 1 plus n, A1, n, M1, n. And this can be written as 1 plus 2 is odd. So this will be minus A1, 2, M1, 2. Plus this is even. A2, 2, M2, 2. Plus so on plus minus 1 to the power of n plus 2, AN2, MN2. Because AN2 is minus 1 to the power of n plus 2, MN2. First example is A is equal to this much. We have to expand it by R1, then by C1, then by R2, and then by C2. And I will show you that the result obtained by expanding it from R1, C1, R2, C2, all these results are same. So solution is, now we have to expand it by R1. We have to expand it by R1. So this will be first entry, 1 into its cofactor. So cofactor of this entry will be plus. So sign here will be positive. This is entry at the 1, 1 place. So sign will be positive. So this will be 1 into. Now for the entry at the place 1, 1, we will delete first row and first column. First row and first column. So this will be equal to this, and this will be deleted. We will get minus 1, 2, 5, 2. Now this is plus, so this will be negative. Minus of minus 3 into. Now second place is this, this into this. This is gone, this is gone. We are left with 4, 2, 3, 2. 4, 2, 3, 2. what we do is we will multiply this entry by its cofactor. So cofactor will be obtained by deleting the row and column in which the entry occurs. So these two will be gone. We are left with 4, 2, 3, 2. And next will be plus. As I told you earlier, you should be cautious while finding the sign of the first entry. So this is 1, 1 place. So this is positive. And rest will be alternate, negative and positive. So this will be 1, 1. This place will be 1, 2, odd. This will be 1, 3, even. So this will be equal to, again, this will be even, and we will delete the row and column in which this entry occurs. So this row will be gone and this column will be gone. We will be left with 4 minus 1, 3, 5. 4 minus 1, 3, 5. So this will be equal to 1 into, this will be minus 2 minus 10. This will be minus minus plus, plus 3 into 8 minus 6. And this will be 2 into 20 minus minus plus. This will this into this minus this into this. So minus of 3 into minus 1 is minus 3. So this will be positive. So 20 plus 3. 20 plus 3. So this will be equal to minus 12 plus, this is 2, so 3 2s are 6, and this will be 46. So this will be equal to 52 minus 12, that is 40. This is first part. Now I take up the second part. Second part is we have to expand this determinant from C1, that is first column. So you should be cautious while finding the sign of the first entry. So sign of the first entry will be, this is 1, 1 place, even place. So sign will be plus. Plus 1 into. Now delete the row and column in which the entry occurs. This is the entry. Delete this and this. This and this is gone. We are left with minus 1, 2, 5, 2. Clear? And now second entry will be this. This is positive, so this must be negative. Minus 4 into this is the column in which this entry, and this is the row. So this row and this column will be deleted. This and this is gone. Minus 3, 2, 5, 2. Minus 3, 2, 5, 2. And for this entry, this will now be plus 3 into. This is gone and this is gone. Minus 3, 2, minus 1, 2. Minus 3, 2, minus 1, 2. So this is equal to 1 into minus 2 minus 10. Minus 2 minus 10. Minus 4 into, this will be minus 6 minus 10. Minus 6 minus 10. Plus 3 into this minus this into this. Minus 6 plus 2. Minus 6 plus 2. And on evaluation, we get this will be minus 12 minus plus 64. And this entry will be minus 4 into 3 is minus 12. So this will be 64 minus 24. So this will again be 40. Now we expand this determinant by R2, second row. Now for second row is first row, second row. This is the second row. Now place of this entry is second row and first column. 2, 1. So this is an odd place. 2 plus 1 will be 3. So sign will be negative. Minus 4 into determinant of this. Delete the row and column in which the entry occurs. This and this will be gone. Minus 3, 2, 5, 2. Minus 3, 2, 5, 2. Clear? And now we can take alternate plus minus. So this is negative, so this will be positive. Place of this entry is 2, 2. This is even. So this into minus 1 into this and this row and this column will be gone. We are left with 1, 2, 3, 2. 1, 2, 3, 2. And next sign will be negative. Minus 2 into. This is the entry. Now this and this will be gone, and we will be left with 1 minus 3, 3, 5. 1 minus 3, 3, 5. So what we do is first determine the sign of this. This is 2, 1, so odd place. So minus 4 into, delete the row and column in which. So this. Next entry will be plus. This minus 1 into, delete the row and column. 1, 2, 3, 2, and similarly this. So we get minus 4 into. This will be minus 6, minus 10. Minus 6, minus 10. This will be minus 1 into, this will be 2 minus 6. 2 minus 6. And this will be minus 2 into. This will be 5, 5 plus 9. 5 plus 9. So this is equal to, this is 16, 16 4s are 64. This is 64, and this will be minus 4, minus plus 4, and this will be 9, 14, 14 2s are 28. So this is again 40. This is again 40. 40, 40, 40. And last is, we will expand this determinant from second column. Now second column, first column, second column. This is the second column. Place of the first entry is first row and second column. 1, 2. 1 plus 2 is odd. So this is an odd place. So we will have to take a negative sign. Minus 3 into. Minus 3 into this, and this will be gone. 4, 2, 3, 2. 4, 2, 3, 2. And we are expanding by second column, so this will be the entry. Now this is negative, so this must be positive. Positive, and this will be minus 1 into. Now delete the row and column in which the entry occurs. 1, 2, 3, 2 will be left. 1, 2, 3, 2. And next is this. So this was negative, this is positive, this will again be negative. And this will be negative of 5 into its cofactor. This and this, 1, 2, 4, 2. 1, 2, 4, 2. So this is equal to 3 into 8 minus 6. 8 minus 6. This will be minus 1 into 2 minus 6. 2 minus 6. And this will be minus 5 into 2 minus 8. 2 minus 8. And this is equal to 3 into 2. That is 6. Minus, this will be minus 4. So minus plus 4. And this will be minus 6. Minus 6 into minus 5 is plus 30. So we again get the result 40. We again get the result 40.